This script just stored a password the right way, and no one can read it back. It hashed it, salted it, and issued a secure token to prove who you are. Even the database owner cannot recover the original password. I am Mahaz, episode 66. Hashing, encryption, and password security. The skills every web app needs. By the end of this video, you will never store a plaintext password again. Every hacked website headline starts the same way: plaintext passwords in a database. One breach, and every user's actual password is exposed. The fix: never store the password itself. Store a hash of it instead. Hashlib built into Python for general-purpose hashing. bcrypt, purpose-built for passwords, slow on purpose. Secrets module for tokens, salts, and safe comparisons. JWT, a signed token that proves who a user is without a database lookup. Today we build the exact pattern behind every login form you have ever used. Hashlib turns any input into a fixed-length fingerprint. Import hashlib, then hashlib.SHA-256 of the encoded bytes. .hex digest turns that fingerprint into a readable hex string. Same input, same hash every single time. That is the point. But SHA-256 is fast. Attackers can try billions of guesses per second. Fast hashing is perfect for files. It is dangerous for passwords. Passwords need something deliberately slow. That is bcrypt. bcrypt designed to be slow, and it adds a salt automatically. Pip install bcrypt, then import bcrypt. bcrypt.gensalt generates a random salt for every single password. bcrypt.hashpoo of the password bytes and the salt creates the hash. Two identical passwords now produce two completely different hashes. bcrypt.checkpoo compares a typed password against the stored hash. It never decrypts anything, it just rehashes and compares. The secrets module for anything that must be unpredictable. Secrets.token_hex of 16, a random hex token. Secrets.token_URLsafe, safe to put directly in a URL. Never use the random module for security. It is predictable, not random enough. Secrets.compare_digest compares two strings safely. A normal equals check leaks timing information an attacker can exploit. Compare_digest always takes the same amount of time to run. JWT tokens and AuthBot are next. This is the exact login pattern real production apps use. 66 episodes. Free. Every single one. One subscribe keeps this series running. For bonus episodes still ahead. Tap it now. Okay, JWT tokens. JWT JSON Web Token. Assigned proof of identity. No database lookup needed. 3 parts, separated by dots: header, payload, and signature. The header names the algorithm. The payload holds the user's data. The signature proves the token was not tampered with. Pip install pyjwt, then jwt.encode of the payload and a secret key. jwt.decode verifies the signature and returns the original payload. Change one character in the token, and decoding fails immediately. AuthBot registers a user, checks their login, and issues a secure token. Step 1. Register. Hash the password with bcrypt before storing it. Step 2. Login. Take the typed password and bcrypt.checkpoo against the hash. Step 3. On success, build a JWT payload with the username and an expiry. Step 4. JWT.encode signs the payload into a token string. Step 5. The client sends that token on every future request. Step 6. JWT.decode verifies it before granting access. Run it. Wrong password rejected. Correct password valid token issued. 3 mistakes that turn a login system into a security incident. Mistake 1. Storing the plaintext password directly in the database. One breach, and every user's real password is exposed instantly. Mistake 2. Hashing passwords with plain SHA-256 instead of bcrypt. Fast hashes let attackers try billions of guesses per second. Mistake 3. Comparing tokens or hashes with a plain equal sign. Use secrets.compare_digest to prevent timing attacks. Your challenge.
Step 1. Write a register function that hashes the password with bcrypt.
Step 2. Write a login function that uses bcrypt.checkPoo to verify it. Step 3. On a successful login, issue a JWT with a 1-hour expiry.
Step 4. Write a verify function that catches expired or invalid tokens.
Step 5. Test it with a wrong password and with an expired token. Reply with a screenshot of your AuthBot rejecting an expired token.
I check every comment.
Let us recap what you learned today.
Hashlib, fast, general-purpose fingerprints. Never for passwords alone.
bcrypt, slow on purpose, salts automatically. Built for passwords.
Secrets, token_hex, token_URLsafe, compare_digest.
JWT, header, payload, signature.
Stateless proof of identity.
Never store a plaintext password. Ever.
Never hash passwords with plain SHA-256 or MD5 alone.
Always use compare_digest for tokens and hashes.
Next episode, working with APIs, advanced patterns. Subscribe so you do not miss it. See you tomorrow.
Password security unlocked.
Hashing, salting, tokens, and JWT all covered.
Your login system just got a whole lot harder to break.
Next, episode 67, working with APIs, advanced patterns. Subscribe. Show me your AuthBot rejecting a bad token in the comments.
I am Mahaz. See you in episode 67.